Okay, an area that is frequently given students some difficulty is translating between a position time graph and a velocity time graph. So I'd like to do a couple practice problems where we go from position time graphs to velocity time graphs and vice versa. So here, let's do this one right here first. So here what I've given you is a position time graph here, and what I'd like you to do is to try to translate that into a velocity time graph. If you want to give that a shot, you can take a minute and pause the video and try that out. But I'm going to do it right now. Hopefully you've given it a shot already. So let's think about what's happening here. There are really three different segments, and in fact, to kind of make this clear, maybe I'll go ahead and drop down some guidelines here. So this is the first segment of our graph, and this would be the second segment of the graph, and then finally the third segment of the graph. As I translate, I'll have those guidelines to refer to. So in the first segment, what's going on? Well, what do I know about the initial velocity? Well, it appears at the very beginning that there is, let's remember, maybe I should back up and remember this essential point. On a position time graph, the slope is equal to the velocity, right? We know that. So the slope is the velocity. That's going to be our key feature. So what's going on here? Well, I've got a positive slope. So that means the velocity must be positive. And what's true about the slope in this first interval? Well, it's positive and constant the entire time. So what does that mean about my velocity? It's going to be positive. So I'm up here in the first quadrant, and constant velocity means a constant positive velocity value. So a straight line just like that. Constant positive slope, constant positive velocity. It's constant, so the slope here is 0. There is no acceleration. How about the second segment? Well, here the slope is 0, which means the velocity must be 0. So where's 0 velocity? We'll just write down here along the t-axis, right? So it kind of drops off apparently instantly, right? There's an elbow here. Velocity is 0. And then how about here? What about this third segment? Well, here the slope is a constant negative slope. So that means the velocity must be a constant negative value. To go a little deeper, this slope, the magnitude of the slope appears to be greater. In other words, this is a steeper slope than this was. So maybe I should go down a little bit farther, down to here. Constant negative slope means a constant negative velocity. And so this negative magnitude is larger than that positive magnitude because the slopes are a little bit different. Hopefully that made some sense. Let's try this. Here I've got a velocity time graph. So what I've given you is a velocity time graph, and I'm asking you to translate it into a position time graph. And here, again, if you want to right now, now's the time to pause it and try it on your own. Here there are really only two segments. There's, if I draw a guideline here, there's this segment here, the first segment, and then the second segment. So let's think about what's happening here. Well, remember, this is sort of the opposite relationship, right? The slope of this graph equals the velocity. So the value on this graph equals the slope on this graph. So going backwards, going in this direction, is frequently a little bit trickier. So let's see if we can unpack it here. Okay, well, my starting position. What is my starting position according to this velocity graph? According to this graph, where do I start? And if you think about it, we have no information about the initial position. There is no information about the initial position, about x initial. There is none. For those of you who have taken calculus, you might remember that if you go from a velocity function to a position function, when you do this, you take the integral and you get that that constant that pops out, that plus c. Well, the c value, which in principle could be anything, is the initial position. So we don't have any information in this graph about the initial position. So what that means is I can start this graph anywhere I want. Maybe I'll choose just to start at the origin. That seems like a logical place to start. So I don't know about initial position. I'm choosing my free choice to start at the origin. But what's true about the initial velocity? I do know something about that. It's negative, right? We're down below the t-axis. This is the land of negative velocities. So what's happening? Well, it's a negative velocity, so I need to start with a negative slope. So I'm going to start off with a negative slope. So what happens to the velocities? Well, the velocities get bigger and bigger and bigger. They go from negative to 0. So what has to happen to my slope? Well, my slope has to level off to 0 at this point. 0 velocity means 0 slope, flat line. So this is the slope of my graph. This is going to be curved, and it's going to gradually taper off to flat line. So it starts as a big negative value, gets less and less and less negative, and goes to 0, flat there. All right, well, in the second segment, what's happened here? The object has stopped. It is changing directions. It's pivoting. And now we're going up here to the first quadrant, the land of positive velocities. And so now my slopes need to become positive, and they need to become increasingly positive. The velocity gets bigger and bigger and bigger. So I need my slopes to get positive and to get more and more and more and more and more positive to that point. And again, this point, those are the same point if I were to draw another guideline right here. Okay, so large negative slope, large negative velocity going to 0, and then pivoting and turning around. Now, since we didn't have any information about the initial position, I could have drawn this exact same graph but started at a different place. In other words, I could have drawn this exact same curve starting up here. I could have drawn a curve that looked like this. Or I could have started here, and it would have looked like this, and all of those answers would have been acceptable. It's a little bit trickier to work backwards, but hopefully that was helpful. That's all for now.